Hey, good afternoon, everyone.
Good afternoon, Damaris.
Thank you.
Good
So
afternoon.
thank you. So I'm going to share my screen. Give me a minute to do so. Let me know if anyone can see my screen.
Yes, we can see your screen. Special data import and exploration.
Yeah, thank you for confirming. Once again, I'm Damaris Kimonge. My background is in applied statistics, but statistics. I'm from Nairobi, Kenya, and the Center for Epidemiological Modeling and Analysis, University of Nairobi. So I do duration, break in between for like 5 minutes or 15 minutes, and then move to the practical bit of it.
Something small. Just 1 minute. The minds have been corrected that our first session is with Rogers. Maybe Rogers, is that the case? Rogers, is that the case? Okay. The Damaris, you continue. We shall just switch. We shall switch with Rogers later.
Okay. Okay, so first we want to understand what is spatial data. Spatial data accounts for the space aspect. For instance, we have mentioned about malaria data sets, and we have said that there is the aspect of having the GPS coordinates. And in our analysis, we want to understand how different locations differ, maybe according to malaria, various species of maybe schistosomiasis. And why we want to understand that is we want to know what is contributing to the disease burden that we are experiencing. Further to model, so we can understand what are the areas or rather locations that are like high prevalence or have a prevalence that than the recommended
Damaris,
Ministry of Health
Damaris,
threshold.
Damaris, we are struggling to hear you.
Spatial data import, what do we need to understand? We have to understand we have different, yes?
We are struggling to hear you. I think network is not stable.
Can you hear me now?
Damaris, we are struggling to hear you.
How about now?
You continue speaking, we'll give you feedback.
Okay, I noticed I dropped at some point.
Yeah.
Can you see my screen?
Yeah.
Yeah. So we have different types of data. Spatial data, as we discussed yesterday, and that is point data, polygon data, and raster data. Point data is what we are referring to the GPS coordinates. Polygon data is what we refer to as the shapefiles or the rasters, which can the shapefiles, and there are also other formats, which are the GeoJSON and the TIFF extensions. We also have raster datasets, which are ideally gridded data points. And we will discuss more on how we get to grid aerial data types, that is like a shape file. So what we need in this is we need to have R, as we said, have R installed, and the packages that we're going to use is SF package. As a preparation for spatial data analysis, we need to understand the data structure, the attributes, and the coordinate reference systems. We have different coordinate reference systems. That is, we can have the GPS, which is usually in degrees, and we can have the reference system as a UTM, which is the Universal Transverse Marketer. And we will discuss on how to transform from one reference system to another system as we move forward. We need to clean and pre-process data for consistency, and this is a very crucial step. In analysis, what usually takes like 70% of your time is data cleaning. So the end results will take like 30% of your time. So invest a lot of time in data cleaning. Another thing, you have to ensure that you have consistent coordinate reference systems, and that's why we will discuss about transformation to ensure that our data sets are similar throughout so that we can be able to merge them and explore them further. And here I want to insist on the use of Google Earth Pro. So it's a good engine that enables us to edit the GPS. Sometimes during data collection, depending on the networking on a certain region, the gadget used to collect the GPS coordinates doesn't pick the actual points. So you may find that you are in Uganda, but then the coordinate points that you're picking for that specific location are coming from an area that is a boundary between Kenya and Uganda. So you need to clean those coordinates so that they all fall within the Uganda extent. This is a snapshot on how the Google Earth Pro looks like. And what you have to do to ensure that you're cleaning your coordinates. I have a search tab whereby I have typed Aparango, P7 School, Uganda. And then I'm getting results. So it can be A, B, C, D. And these are possible locations that the Google Earth is giving me. And I will choose the most relevant location. I will drag my pin to the area where I want to have the coordinates. And then this window will pop up. It will give me the latitude and the longitude. But this is in the UTM, which I referred to, the Universal Transverse Marketer, which is ideally the northings and the eastings. So how do I move from here? Because at the end, I want to have the coordinates, which are in decimals. So I will move to another online resource whereby it's a calculator that enables me to convert from UTM to decimal degrees. So 2 degrees, 5 minutes, 2 degrees, 5 minutes, 21.34 seconds. For the latitude, 32 degrees, 51 minutes, 22.47 seconds for the longitude. So this is basically what we have here. And I'm giving an explanation on how to calculate, to input the values in the online calculator so that you can be able to get the decimal degrees, latitudes, and longitudes. So that's a very crucial step of data cleaning. During our practical session, we will get a chance to see what the results that we get if we fail to correct for the wrong GPS coordinates. Okay. So that's an introduction to spatial data cleaning. I understand that the other bit has been moved to tomorrow's session, but really my desire is to spend more time on the practical bit of it so that every one of us gets to understand and get the ability to perform the spatial analysis on their own. So for the sake of time, I don't know if we break or we just proceed to the practical session.
Thank you so much, Damaris. If you still have more content, we could continue such that if we can save more time, the better, because we are fixing in some new sessions like the use of GitHub, but also individual projects. So if you have some content you can cover today, please proceed. But there is a hand up from Victor.
Yes, I have a little bit of question. So this process that you just explained now with converting degrees, what if I've done it before and I kind of got the same thing like latitude and longitude. If I just Google, for example, if I want to find the longitude and latitude of Makerere University, I just Google longitude and latitude value of Makerere University and I get it. Will there be like variation in the degrees and the latitude and the longitude thing? Or maybe this is much more accurate per se.
Okay.
Did you get my question or should I repeat?
If I get you are asking what if you Google the GPS coordinates from the Google Earth Pro, but then end up getting the same coordinates. And my question is, are these coordinates within the shapefile? Like, are they with, for instance, if the lowest limit for latitude in Uganda is -2.4444, and the highest is maybe 35.222, the lowest limit for the longitude is -4, the highest is 40. So is the value you're getting within these limits that I have mentioned? If no, then you have to redo it, like refresh until you get the correct value. And if that's not what you're getting, check the shapefile that you are using. Is it an updated shapefile?
Oh, okay. Okay, thank you.
Yeah. Any other question?
Under what circumstance do you have to go through this, I will say, for lack of a better word, manual process?
Usually 90% of the time, because the networking in Africa isn't really that good. So meaning that even the gadgets that we use, for instance, if we use ODK will perform depending on the networking of the location where you are collecting your data. So if it takes time to pick the actual locations, and then it means it is going to give you GPS coordinates that are not the exact coordinates for the location. So 90% of the time, we will have to clean for the GPS coordinates. And how do we know that the coordinates we have are falling outside the shapefile extent? We know that by plotting the points on the map.
So does it help you, supposing I know the name of the place, but I don't have the coordinates, for example, or I'm not sure, I'm trying to verify the coordinates. Under what circumstance do we, so I think maybe I didn't speak it well. Maybe help me to emphasize it.
So you have the name of the location, but you have the wrong coordinates. GPS, Google Earth will help you. Sometimes you have the name of the location, but you don't have any GPS coordinates and you want to extract the coordinates from the Google Earth Pro. So that's how Google Earth Pro helps. Sometimes you have wrong coordinates, sometimes you don't have anything. Did I answer you?
Yes, very well. Thank you so much.
Okay. Maybe what I can do is maybe a quick, I can take you quickly through the Google Earth Pro engine and how it performs. We try to search a school, we try to get the degrees, the coordinates, and then we try to do the conversion so that when you get to doing it, it will be a bit easy. And then after that, we will move to the practical session of it where I will discuss more and more. This is how Google Earth Pro looks like. You have to install it in your laptop or computer, just like you install any other application. So after installing it, let's say we are interested in a specific school. And we specify that this is a school in Uganda. So it has given me options. And from these options, I'm going to scroll through to see if there is anything that relates well to the school that I'm interested in. If not so, I have to refine my search. Maybe give it more information. And then it gives me one option, which is A. And when I hover to this location here, I can see where A is. So what I'm going to do is to pin this location by using this yellow icon here. So once I click on the yellow icon, there's this pop-up window. So the window gives me the coordinates for this location A, which is probably where the Aparango Primary School is located. So one of the interesting things with Google Earth Pro is that you will not be able to maybe minimize and then move to a different screen, because the moment you do so, it disappears. So the easiest way is to write these numbers down. After you do so, hoping that you've written the number, transform the coordinates, decimals, and degrees. So, and then I share another window. Now that this is Chrome, which gives me the calculator that I want to use. So share again.
Excuse me, is Google Earth a free software?
Yes, it is a free software.
Damaris, do you mind if you give us 5 minutes? Does it take long to download so that we can be at the same pace with you?
No, it doesn't.
Yeah, you could give us just some 5 minutes and we download and then we do exactly what you are doing.
I think we are
Okay.
coming to a practical session later on. Isn't that the case, Damaris?
Yeah.
Okay.
Okay. So the next thing I will check is the online. I share my desktop. So let me know if you can see my ROM. Are you able to? Are you able to see my screen?
Yes, we are able.
Okay. Yes, I have here. There are several of them, but I prefer using this one. Yeah. So you feed your coordinates here. So we had 2 degrees. I'm going to put them side by side. So 2 degrees, 2 degrees, 5 minutes, 21 seconds, 21.34 seconds. 21.34. And then for the longitude, we have 32 degrees, 51 minutes, and 22.47. So I'm going to feed the numbers here, 31, 51, and 22.47. And then I say convert to decimal degrees. So immediately I get these numbers, coordinates. So one thing to note here is that if the location is on the south, so if the latitude was 2 degrees, 5 minutes, 21.40 south instead of north, and then a must thing to do is that once you convert, you have to include a negative on the latitude. If the location is towards the south, always include a negative on the converted coordinates, specifically on the latitude. I think that is all. So kindly let us move to the practical session, because now that will give us the opportunity to identify the areas that we want to clean and practice what I have just demonstrated today.
There is a hand up, but I also have I have a suggestion, but there is a hand right now.
Okay.
Yes, my question is, you said, I really didn't get it quite well. You said if it's on toward the south, is it south of the equator, or I mean, I think I didn't get it quite clear.
South of the Greenwich meridian, which is the equator.
Okay, maybe you could just repeat that one more time, please, because I really didn't get it quite well.
Okay. So, okay, let me illustrate it again. So this is Google Earth Engine. And I have searched for this school, which is here, this location. I pick my pin, point it here. Sometimes if you feel like the location given isn't the actual location and you want to adjust, you can move this pin around. But for accuracy, I always place the pin on the location, which is this letter A here. So immediately I do so, the coordinates are generated, and that is in form of latitude and the longitude. So for the latitude, I have 2 degrees, 5 minutes, 21.53 seconds. And then I have N here referring to north. For the longitude, I have 32 degrees, 51 minutes, 22.50 seconds. And I have letter E referring to east. So this implies that my school is located towards the northern part of the Greenwich meridian, which we can also call as the equator. So if that is the case, I will convert these values using the online calculator and retain the values as the calculator generates them. But supposing this is letter S, which is south, this school is located to the southern hemisphere. And then after calculating using the online calculator, the first thing I'll have to do is allocate a negative sign here. So in that case, let me try. So assuming this is 2, 5, 21.47, but from Google Google Earth Engine, the latitude at the end, I had a letter S, which is to the, meaning to the southern hemisphere. And I have my longitude as 31, 51, 22.47. So I'll have the conversion, but because this was towards the southern, I will include a negative here in this number. So that when you're going to map, the school will be located in the actual location. That's to mean that this calculator has no ability to take the southern or the northern. So you have to have the understanding that it's you who will interpret these results at the end and include a negative always when the location is towards the southern, and retain the generated values as they are if the location is towards the northern. Did I answer you?
Yes, it's clear. Thank you so much. Very clear. Thank you.
Okay. So I suggest we move to the practical. And as you know,
Well, Damari, I want
yes.
to just get you straight.
Okay.
Is it that for R, we only use the coordinates in decimal degrees? And then, I don't know if I've just forgotten, but as if there's an option for converting units in the Google Earth Pro engine.
So another option you can use is QGIS, but then I have never used that. The safest that I know is Google Earth Engine. Secondly, on your first question, if we must work with decimal degrees, not necessarily, but the type of analysis you want informs the conversion that you will use. So for instance, if you want to map the locations, and then you will need to convert so that you use them in decimal degrees. If you want a gridded area, you will use the northings and the eastings as they are, but then that will require you first to do a reprojection of the coordinates using the correct hemisphere, which for East Africa is, I think, 37 towards the south. So it really depends on the end results that you want and what you want to communicate.
All right, thank you very much.
Damaris, could we just go back a bit before we come to this one?
Okay.
Let's go to the other, go back a bit. I want us to choose a school which we know in, say, in Kenya, and we see how the coordinates come through. Yeah, at that point. Let's choose a university, or let's choose let's choose a university which we know its location, and we see how that works and how it progresses.
Okay, give me a name.
Maybe let's put a University of Nairobi.
Sorry, I'm typing in capital letters. So it gives me quite a number of options because there are several campuses under the University of Nairobi. So each letter given is also represented on the Earth Engine. So if I am interested with the main campus, which is A, or maybe Chiromo campus, which is C. And then what I will do is come to the Earth engine, locate it here, pick my pin, place it here on top of the location. Mhm. It's not giving me a pop-up window, so let me see what's happening. Mhm. I understand why it is doing so. It's because initially I had another pin, which is probably still active. So what I will do is restart the engine. And then do my search again. University. Kenya. So okay. So I have Nairobi. Then I will save my coordinates somewhere, probably writing them down. So after doing so, I will locate my online calculator and feed in the numbers, which is 1, 16, 22.38, and 36, 48, 18.25. Convert, obtain the latitude and the longitude, but remember, this was towards the southern, so at the end, I will include a negative here. Does it match what you have?
Myself?
Yeah.
No, I just wanted to see how it happens to a place where the coordinates are known. So I didn't have like another comparison. I'm just happy to
Okay.
learn this, yeah.
Yeah. Yeah, so that is it. You can do quite a number. So you can search maybe
Yeah, let's try, maybe those ones are popular. Let's try another. Amina, can you get in your work, do you have any sport that that you would be very curious about? Let's try Vugoye, Health Center 3, Vugoye. As Amina is thinking, Vugoye, it is BU. It is BU. Yes. Bugoye. Health center, yes. Yes.
So I have two options. I have Bugoye Health Center 3, and I have Bugoye Health. Oh, they're more of the same, but this is Uganda.
Yeah, that is, I think that one is more close.
So,
That one, B.
okay. So I will locate B, but first of all, my pin disappeared, so I have to find it.
Okay.
Yeah. So I'll place it somewhere. And then I minimized something. Which I think is going to be problematic. Something I minimized. I minimized the window that was giving me the coordinates. Let's see what I have here. So that's the disadvantage that if you minimize something, it just disappears and you cannot open two windows at the same time, or you cannot perform two things at the same time, because immediately you switch from the Google Earth, everything disappears. So I don't know the easiest way to locate it. So what I usually do is to just restart. And then pick my pin again. Place it on top of the red icon. So it's towards the northern. So I know what to do once I calculate them. So a disclaimer is that it is a tedious work to do, because searching for like 10 schools will take you like 1 hour. But then that is the element of data cleaning, and you have to do it. Okay. Any other question?
No, thank you so much.
I have a question.
Mm-hmm.
So in an instance where you're working with more than one area, let's say you have a couple of districts you're looking at, is it possible to have a whole lot of all the downloads in one file, or you have to do everything individually?
So let me get you clearly. A download of the...
Let's say you need a number of, let's say, the variables in different, let's say, districts, for example, in Uganda. Is it possible to have everything downloaded into one file, saved and downloaded in one file, or you have to do each individually? For example, if you're looking at Kampala, whatever you need in Kampala, do you need to only download a Kampala, let's say, shape file, or You can
Okay.
have like a variety, everything all piled up into one file.
Okay, so a shape file, shape files, we have different shape files for different administrative units. So the first shape file is shape file 0, which has no boundaries for the districts. That is for Ugandan case. We have another shapefile which has the boundaries for each of the districts. And if you are interested with Kampala, what you will do is that you will have this one bigger shapefile, but then filter Kampala. So like there's no shapefile that is specifically for Kampala and another one for a different district. They all come in one shapefile, and during analysis is when you filter the location that you want. In this case, you only want Kampala, so you will filter out Kampala and form a small shapefile that is for Kampala that is suitable for your analysis. For the Kenyan context, we have shapefile 0. For the entire Kenya, we have shapefile 1, which has the counties in Kenya. And then we have another shapefile for the wards, all the wards in Kenya. So if I am interested with the counties, I will take the shapefile number 1, which has the boundaries for the counties. And in this, if I'm only interested in Nairobi County, I will filter Nairobi County and form a small shapefile and use it in my analysis. If I am interested in wards that are in Nairobi County, and then I will use the ward shapefile, which comes with the name of the county and the name of the ward. So I will filter out wards that are in Nairobi County and perform my analysis in this small shapefile that I have formed. So you get everything from a bigger scope and then filter out to suit your analysis. Okay. Any other question?
I'm just wondering, when do we need Google Earth? Is it just for getting the coordinate and then you enter it in your data set or what? Or it has something more than just getting the coordinate of the given point?
So when you need Google Earth is 1, you have plotted the points. For instance, the schools, you were interested in schools that were tested for schistosomiasis in Kampala County, and you want to see the different species of schistosomiasis across the schools. And you have school A in Kampala County with the number tested, the number positive. You have another school B in Kampala County, Kampala district with the number tested and the number positive. And what you want to communicate is that you want the reader or the policy maker to understand that school A has both species of schistosomiasis. But then when you plot that on the map, school A and school B, you find that school A is outside the Kampala district boundary. So that means that school is not in Kampala. And what is causing that is because the coordinates that you're using for that school are not accurate. So you need to correct them so that you can map again for school A to fall in Kampala. When we move to the practical, we will plot a map and see some of the points that are outside the shapefile and decide on how to edit them. I think that way it will be clear. Like you just don't start cleaning the coordinates before identifying a problem. And how you identify the problem is one by plotting the locations that you have on the shapefile.
Yeah,
Am I
thanks,
free
Carol.
to move? Okay. Am I free to move to R? We will redo everything that we have discussed when we get a problem that relates really well to the work that we are doing. Okay, so if we are ready to do so, I would want us to have a shapefile for Uganda schools, and that can be downloaded from this site. I'm going to paste the link in the chat box so that you can be able to download the schools. And now I think it's safe to only share my R window instead of sharing everything.
Are we downloading primary schools or all?
Primary schools.
Okay, thank you.
So that is locations of primary education schools in Uganda. So let me know when everyone is ready to begin.
Damaris, I'm not sure if our new members who came in today also have the R uploaded. Maybe we could double check that as well.
Okay. So let me see. Okay. So do we all have R installed? We can't remember the name. Let me see. Maybe by a show of hands, if we have R installed. Okay, thank you. So that is Phoebe, do you have R installed?
Yeah, I do, but it has still refused to update the packages that we were trying to upload yesterday.
The RGDAL.
I didn't get that.
Which package?
We tried to upload Tidyverse, Rasta, SP, those ones.
Okay, so maybe you can share your screen at some point so that we try to troubleshoot. So Amina, Bashir, Calvin, Solomon, Victor.
Oh, I have
Okay,
yeah,
thank
I'm
you.
ready. Yeah.
Thank you.
I also do have R.
Okay. Okay. So we have like 1, 2, 4 of us who do not have R installed.
I also have it.
That's Calvin. So 3, Amina, Solomon, and Victor. So kindly download R. Abel, do you mind sharing a link on the chat box so that they can be able to download R?
Okay, let me do that.
Okay, thank you. Okay, Phoebe, you were sharing your screen and you stopped.
I wanted you to see the error message I get.
So it's install.packages into bracket SF, and SF is in quotation marks.
Sorry, where are you?
Okay, let me, what you have on the, here, maybe write it as install.packages and then have a save in quotation marks, this one.
Oh, this.
No, the SF. So put the quotation marks. Retain the brackets.
Oh, I still keep the bracket.
Yes.
Like
Then
that?
try, yeah, then run that.
Maybe I try uninstalling and I
Yeah, it's
install what I've
downloading. So
installed.
yeah. Mm.
Download.
Yeah, it's downloading. You see the red button?
Mhm.
Yeah, so don't quit until it goes off. And then you can library to see if the package is installed. Another way that has been suggested is to have Pacman and then call the libraries from it so that the libraries will automatically be installed if they are not yet and be libraried at the same time. Thank you for that. So install and give me an update. Just try calling it library. Library to bracket SF. And you have the R tools installed.
I actually downloaded an
It is not.
intermediate package and I installed it.
Your R tools, you have a warning. R tools is required to build R packages, but is not currently installed. So these are like the drivers that will enable the R packages to run. So you have to have them installed first. So you can go to Chrome and search R tools for Windows. Then download and install just the normal way you install any other application. So after you do so, try reinstalling the packages and give an update of the progress afterwards. And I would want to insist that during the practical session, it's good to listen, take notes, and then afterwards, if there is anything that is not working, we can make a follow-up. But the important thing is to listen and get the concept. So I'm assuming that we all have the school shapefile installed. If that's not true, let me know. Amina, okay, you are. Have you downloaded R? Let me know who is ready to begin.
Yes, I have downloaded it.
Okay, thank you. Catherine, are you ready?
Pardon, I missed something.
Do you already have the school shapefile downloaded?
Not yet.
Kindly download so that we can begin. Bashir?
I'm okay. I'm okay.
Okay, thank you. Phoebe, let me know when you're done installing the R tools. Because I want us to move together.
Damaris, Catherine here. I've downloaded, but I'll request that maybe you proceed
Okay,
because I'll
thank
be
you.
going in for another meeting, but I've downloaded. Thank you.
Okay. So is everyone ready to proceed?
Yeah, let's go.
Yes, please.
Okay. So so the first thing to do when you're working with R is documentation. Ensure that you document your work. And from the script that I'm sharing, I have the title of the work. I am including the date. So today is on 12th of March. And why I am doing this is to help me keep track of the changes that I will make in the future. That's concerning this work. Another important element to do is that you want to clear your memory so that you don't have anything that is not related to the current work running in your background or in your R session. So we want to clear the memory, like it's like opening a new chapter. Another thing we want to do is to set the working directory. That's where the folder in our computer where we will save our work, where we will load our files from, so that each time we don't have to specify the full path of the folder where our files are. So in this case, I have set my working directory to be Damaris, Dropbox, Dama here. So what will happen if I fail to set the working directory is that each and every time I try to call a file, let me use this an example and try running it, I'm going to get an error. So this error is telling me that this specific file cannot be found in the directory where I called it from. Another thing is to ensure that you have the packages that you're going to use installed and libraried. So in this work, we are going to use the SF package. As early discussed, SF package enables us to do the mapping. We are going to use the dplyr package, which will enable us use the function pipe. And what I mean by in this case is that I want R to read this shapefile. And then once it reads the shapefile, I want it to perform the next operation on the same shapefile. It's like a chain of events in one. And then I have another package, which is read Excel, which will enable me read data sets that have the extension of XLSX. Another package is tidyr, which will enable me transform files from the wide format to long format. Long format is where you have observations with the same unique ID, but repeated throughout. While wide format is when you only have one observation, that is one row with entries that are specific to that row. Like you don't have any repeating entries for the same ID throughout your data set. I'm going also to make use of ggplot2, which is a package that enables us plot bar graphs, pie charts, and even plot our maps. I'm going to require data.table, which will help us transform the geometries. Sometimes we want to drop the geometries so that we can convert our data sets from a shapefile to a data frame. I'm going to require write Excel, which will enable me to save the cleaned data sets back to my working folder so that anytime I want to perform an analysis, I don't have to go through the whole process of cleaning. I can directly call the dataset and proceed with the analysis without redoing any cleaning again. I have a raster package which will help me read rasters. As we mentioned, raster files contain information that is gridded, and these grids, we call them pixels. And then I need ggspatial. The ggspatial is what is going to give me the scale and the north arrow on the maps that I plot. So for each package that you use it, because you don't want to log. Okay, so once I have my packages loaded, the next thing I want to do is to load the datasets and the shapefiles that I'm going to use. So at this point, I am loading the shapefiles and at the same time cleaning using the pipe operator, which is coming from dplyr. Alternatively, if you find this complex, and then you can decide to load the shapefile. After loading the shapefile, again, write another command separately, which will look like this. Which will enable you execute this code. So it really depends on what you're comfortable with. And we have different packages that can perform the same task. So in this line, I'm going to load my shapefile. This is the Uganda shapefile. And then from it, I want to get only the unique districts. Because what I noticed is if I load it, this is Uganda, I end up getting 136 districts. And when I try to search for duplicates, it notifies me that there is a duplicate district, which is Arua. So we need to drop this duplicate so that it doesn't interfere with our analysis. So ideally, this is what this line is doing, reading the shapefile and retaining only the unique districts. So I'm assuming this is the district name. And this is the geometry to that district. And what we can notice here is that our geometry is in decimal degrees. Okay. And then if you wish, you can also print the duplicates. So here you have them. Another shapefile that I want us loaded is the school's shapefile. And why we need it loaded is we are assuming that we conducted a survey in Ugandan schools where we were testing for bill.
Excuse me.
Mhm.
The shape files for Uganda, was the link shared? Because I don't have it. At least you shared the link for the schools, but for Uganda districts, was they shared yesterday or something?
No, I'm using the shapefile that was shared by Rose.
Yes, it was shared in our emails yesterday.
Yeah,
Okay, that's fine.
Solomon, if you check in the email I forwarded to all of you.
Yes, thanks. I recall.
Okay, thank you. So why I want us to use the school shapefile is that in this practical session, we are assuming that we have conducted a survey in the Ugandan schools, and we want to understand the number of children that are testing positive for bilharzia from the various schools. And what we will need, the variables that we will need in our data set is the number tested. We will require the number testing positive for any species of bilharzia, which I refer to as NESCH. And then we will also need a variable that is giving us the number testing positive for schistosomiasis mansoni. Schistosomiasis is a scientific name for bilharzia. And then we will also have another column that will give us the number of children testing positive for schistosomiasis imatobium. So in line 33, I will use line for easy reference on your end so that if I mention line 33, you quickly can find where line 33 is. So in line 33, I'm going to load the shapefile, and the function I'm using to load the shapefile is st_read, which comes from the SF package. Okay, so if I do so, I'm interested in knowing the columns that are in the schools shapefile, and I will use names function and then type the shapefile name, which is schools, and then enter. The beauty of R is that you can write your commands on the console if you don't want to interfere with your arrangement of the codes. So, and the output I get is a list of columns that are available in the school's shapefile. So I can see I have the longitude, I have the latitude, I have coordinate, and I'm interested to know how the coordinate is different from longitude and latitude. And for me to have a better glimpse of this, I can highlight the schools and then run. Alternatively, I can open it here like this. Better still, I can type view schools and then run this. Okay, so I have the object ID, which like a unique number allocated to each of the schools. I have the district name, I have the school name, I have school type, and then I'm not able to interpret this and this, but then I have geometry, and this geometry is in the universal transverse Metaka format. I have the extracted coordinates from the geometry, that is X and Y. What we are doing right now is we are trying to understand the attributes that are in this shapefile. And then another thing I have is I have the long and latitude, so I want to locate where they are so that I can see the format. And this is in decimal degrees. Okay, so at least I have identified the columns that I will use in my analysis. So you notice if I highlight this and then run, on my end, I am using Control Enter to run. For Windows, I think you will use, I don't know, is it Control? Yeah, I'm using Command Enter. So I don't know what that is in the case that you're using Windows, but it's a short key for running the R code instead of having to locate the run icon and then run. But then if you're not comfortable with that, you can still run. Highlight the line that you're interested with and then run. So if I am interested with everything, because here I have 1, 2, 3, 4, 5. I have 5 lines which are being executed at once by the help of the pipe. So if you want to run everything, and then you can press your cursor anywhere, and then Command Enter or just run. So you will get the results, and these the results you get.
Damaris? Yeah, I think we are leaving some behind. What's the plan? Will you give us chance to do this, or you want us to go with you, to go alongside with you? I have
wanted
two colleagues who are struggling to get the shapefile for Uganda. I think let's first of all pick them up from there.
Okay.
Yeah. Maybe we could first stop sharing and then we help them to get the Ugandan shapefile for districts, and then we proceed. Process, do you want to guide on where they can get the shape files?
The folder that was shared in the email, if you open it, it's one of the files in the folder. If you open it, it will end with SHP. It has SHP file on it. If you open the Uganda Districts 2020 folder,
Maybe what they need to do is to first unzip the folder. It won't load with the zip.
maybe by the show of hands, we could know those that are struggling so that we can help them. Then I think Damaris can go on since there is no response.
Okay. So we had loaded the school shapefile, and then we selected 3 columns. That is the district name, the school name, the longitude, and the latitude. We want to work with 2 districts, that's Apak and Arua, and for us to achieve only these 2 districts, we are going to use filter function, which is coming from dplyr. And then another thing I noticed from the school's shapefile is that there are those where the longitude and the latitude was indicated as 0. So let me show you. There are quite a number with 0 longitude. But then even though we can use the geometry which is in UTM to get the decimal degrees coordinates, in this case, my intention was to only work with a few numbers so that the execution time won't be long from your end, and to make everything easy and as simple as possible. So
There is a question. Those schools that have no latitude and longitude, is it possible to use the other technique that you showed us of Google Earth to be able to locate their latitudes and longitudes?
Yes. Yes.
Okay, just wanted to confirm.
You can use, You can use the Google Earth Pro to locate the longitude and latitude. This geometry, we can extract the coordinates from, and then transform the coordinates from the northings and eastings to decimals and degrees, which we want. Just a clarity on that too. Okay, so after doing that, we obtain 650 schools, 244 schools, and these 244 schools are coming from a park and a RUA, and they are schools without zero coordinates. In case you might be wondering how comes like we only have 244 schools. And then another thing we have done is that we have created a new column, which is a variable containing the information on the number of children tested in the schools. And for us to see that is by viewing the data set, and we can see that we have a new column, which is number tested, and we have 40 throughout because we want to understand, we wanted to retain the same number throughout the schools so that we can see if we test 40 from 20 schools, how does the proportion of those testing positive vary across. And I'm doing this because I don't have a data set that I can share. Like all my data sets are confidential. But then the beauty of doing this is I'm also introducing or refreshing our minds on some of the basic data cleaning aspects in R. So I want to create 3 more columns. And I'm using the set.seed function to enable me execute the same sequence of random numbers each and every time I try to generate the new the numbers. So
now, Damaris, just a minute. Let's hear from some members if they are where you are, if they are following.
Okay.
I'm conscious of my visitors who came in. Let's hear from Amina if she's okay, or we need to step back a bit. Amina, are you okay?
Yes, I am.
Have you been using R?
Yes, I've used it before.
So, okay, that's okay. Calvin, are you fine?
Yes, please. Yes, I'm still okay.
You're following?
Yeah.
Okay.
Okay. So I'm creating new columns. And the first column that I'm creating is any schistosomiasis referred to any SCH here. And why I am shortening the name, like instead of having a column name going by any schistosomiasis, is because R doesn't pick like there is a defined way for R to read columns. And in this case is that R is sensitive to spaces. So I would use something like this and call this a column name, but then including a space, I won't identify this as a column and it will give you an error immediately you do so. So I will try it here so that we all see the type of error that R is going to give me. Already, R is highlighting this as an error. If you all can see the cross, the red cross, and it's telling me there's an expected token that is schistosomiasis. It's picking schistosomiasis because there is a space in between any and schistosomiasis. But if I retain what I had initially, R is very comfortable with this. So I'm using the mutate function to create a new column, and mutate function is coming from the deployer package. And then I want R to give me numbers that are between 0 and 15. And I'm doing the same for SM, which in this case is schistosomiasis mansoni. But then I'm introducing something new, which is the p-mean. And in this case, what I want R to do is that to give me random numbers between 0 and 10, but these numbers should not exceed the numbers I had in the any schistosomiasis column. Why am I doing this? Because if I say that I tested 40 children, and then out of these 40, the number that tested positive for schistosomiasis mansoni and hematobium cumulatively is 15, then I don't expect the specific species to be more than the cumulative number. So maybe once I run and then we view, so I am using the p-mean to limit the numbers that I have in the schistosomiasis mansoni and hematobium columns, because if I didn't do so and say under any schistosomiasis the number is 5, then there is a possibility that any of these columns will be more, the numbers in any of these columns would be more than the cumulative number. For instance, I would have had like 8 testing positive and maybe have 7 testing positive. And then if I check the cumulative number of schistosomiasis, which is 5, then it doesn't make, mathematically that will be wrong. So it's the basic mathematics that I am doing here, where I don't want the numbers to exceed the cumulative. So that is the purpose of the p-mean in this execution. So once I do so, I'm comfortable, one, because I have the columns that I require, I have the number tested, I have the longitude and the latitude, I have the cumulative number testing positive for any of the species, and then I have the number testing positive for each individual species. So at the end, the objective is to map these the schools which will test positive for both species, that is, testing positive for mansoni and testing positive for hematobium. And another thing we will want to do at the end is to see the proportion and categorize it so that we can see at a certain level, if the Ministry of Health says that if you are within the prevalence at a specific school is 1%, and then there is no need to treat, then we will be able to identify which schools do not need our attention and which schools need our attention. And that means we are going to allocate resources to the schools based on need. We are going to treat based on need. Like we are just, the policymakers are not just going to decide to treat the schools randomly, but rather they have data that is informing them on the specific schools to treat. Okay, so another element that I want to do next is to drop the geometry, because I want this to be a shape, a data frame instead of a shape file. So for me to do that, I am using the set DT, which is coming from the data.table package. And why I want to drop the geometries in this case, why I want to drop the geometries in this case is, one, they are in UTM. Two, these are geometries that are specific to the school. And what I want at the end is to map within the two districts. So I want to aggregate the information to the district level rather than retaining like the schools. So for me, I feel it's safer to use the geometry that is coming from the shapefile for this work. So that's why I'm dropping the geometry. Remember, every execution, every code you're writing down has to be informed by your objectives. Why are you doing this and what do you want to achieve? So it's like you have a roadmap, you have a plan of what you want to achieve at the end, and you are doing everything that will enable you to achieve your desired results at the end. Okay. So
I didn't, excuse me, I didn't fully understand the rationale for removing geometry. Even if we don't need it in the subsequent analysis, does it hurt if it stays there? Will it influence our outcomes, our graphs, for example?
yes, it will influence our results in this case, because one, instead of mapping to the extent of the district level, R will map to the coordinates. Okay, let me show you what I mean. So if we look at the numbers here, or this is 32.82293, and this is 2.43, so. And if you move to another school, we have a different coordinates. But then I want to map these schools within a district, meaning I require to use a shapefile that is coming from the district, not a shapefile that is coming from the specific coordinates. I want the schools to fall in the district. Did I answer you?
Yes, partly. My point was that yes, even if we have the data coming from the district, we can just use it, ignore the geometry variable, Or do we just want to eliminate it so that maybe it doesn't cause any confusion at some point? Otherwise, in my opinion, I was thinking that even if it is there, it wouldn't affect us as long as we know that we're picking the shape files from the district and not necessarily from the schools.
Okay, so that's correct, but then okay. I leave it at there.
Yeah, sure, no problem.
Okay. So the next thing we're doing is we want to create a column that will contain the species and give us the presence information. So early on, I mentioned why we require TidyR. And I say that we require TidyR because it will help us to transform from the long format to the wide format, or from the wide format to the long format, like transforming the data sets to suit the analysis that we want to perform. So we're using the TidyR here. And what we want to do is to transform this from wide, is it really from? We want to transform from wide to longer. So remember the change of the object name? Because I want to retain my raw data set so that I can always refer back to it. So I have decided to create a new object, and in this case is the name of a new data set that is transformed to the long format. And what this data set contains is the species. Remember, initially we had SM and SH column-wise, but now we have it row-wise. So after doing that, I want to create a new column, which is the parasitic species, because I want to give sensible labels. Please note that now SM and SH are no longer variables. They are labels for the species column. And for the labels, you can assign anything. And because labels will be used in making the maps, or maybe making any graphs where you want to see how a certain category is comparing to another category, then you would really want to give sensible labels that the reader can easily interpret. So I am going to change the codes, which is SM, to Schistosomiasis mansoni, and in so doing, I am creating a new column, which is the parasitic species, and I am using the record function. This is what enables me now change. I'm avoiding the name replace, the word replace, because replace is a function in R which performs a different thing. So I am avoiding to use it, and that's why I'm using change. So I'm using the record function to change the names from SM to Schistosomiasis mansoni and from SH to Schistosomiasis hematobium. So once I do that, I again decided it would be safer actually to show the map for one district only, but there is no harm if you choose to retain all the districts. So the choice on to what extent you can go will always be guided by your goal, your end results, what you want to communicate at the end. So after doing so, I want to join the data set to the shapefile, which is the Ugandan shapefile. But for me to do so, I have to ensure that I have unique labels under the school endemicity for a pack dataset. And I also have unique labels for the Uganda shapefiles. So, okay, I want to run this code up to here, where I am doing the recording and then show what I get at the end. The names have changed to schistosomiasis mansoni and hematobium, something a reader can easily understand. And at this point, I have a PAC and I also have a RUA, but I want to work with a PAC only, so I include a line which is going to filter to a PAC. And then at this point, I try to check what else can I do. So what else to do is to check how the names are matching between the school's endemicity, a PAC dataset, and the Uganda shapefile. So a function that you can use is setDiff. And in this, you have the dataset and the column that you want to check across. In this case, I want the district name. And I want to see if the names in the school's district name, district data, the names in the school districts column are the same to the names in the district name 2019 in the Ugandan shapefile. So if I do so, R tells me that a pack is found in the school endemicity APAC dataset, but doesn't exist in the Ugandan column. So I want to see what a pack is written like in the Ugandan shapefile. So the easy way to check is open the Uganda shapefile, filter, type APAC. And then we see APAC is in uppercase in the shapefile, but it is in sentence case in the school now data frame. So that is bringing in another element of R whereby we say R is case sensitive. So the way R is interpreting a pack in the sentence format and a pack in uppercase is that these are two different labels, two different names. So for consistency, I recorded the name APAC in the school data frame to uppercase. And why this specific column is because at the end, I want to join the school data frame with the Uganda shapefile using the district name. And for me to join the district name, it means I must have same values in the district name under the school data frame and same values in the Uganda shapefile district name. So I have successfully recorded APAC from the sentence case to uppercase. So if I try to check the difference by running this code, R tells me I have 0 labels that are different. Okay. So I'm hoping that you are documenting so that by the time you are going back to the script, you can easily remember what was happening at what point. So here, I want to join the school data frame with the Uganda shapefile so that at the end, I can be able to map. So I have assigned a different object name, and now I'm calling it schools Condemicity APAC 1. And it will contain columns that are coming from the school data frame and those that are coming from the Uganda data frame. I like working with the columns that are relevant to the analysis because that way I can easily view what I have instead of viewing several columns of which I don't require 50%, and it makes my work easy. Okay. So in line 66 and 67 is where I combine the school endemicity data frame with the Uganda shapefile. So this is the school endemicity data frame. This is the Uganda shapefile. And I am assigning the name school endemicity APAC 1 to the new shapefile. So at the end, what I will get is a shapefile because Uganda is a shapefile and it has geometry. If I join a data frame with a shapefile, I end up with a shapefile. So I'm using the function by.x dist name. Dist name is the district name under the school, and dname 2019 is denoting the district name under the Uganda shapefile. So what I'm telling R to do is to merge dist name and dname 2019 elements and consider that these two columns are the same. So that's what these two lines are doing. Okay. Error in merge, dist name by this, merge onto SF objects not supported. So I'm going to view the class of my school, and it's a data frame, and also view the class of Uganda. It's a SF. Ensure that I don't have any geometry. Oh, okay. Let me see where the problem is. Geometry. So I don't think I have dropped the geometry in line 46 because, so I am going to drop it and show you what I get. Schools, HDG schools.
I think column names are not the same.
Mm,
You check the column names in both data frames.
the column names are not the same, but the first error is in line 46 where I am trying to drop the geometry. And there seems to be something that is not working here because it is telling me that I have invalid use of a pipe placeholder. So let me ensure that data.table is loaded. And then let me see what this means. Prediction. Okay. I think I know where the problem is. Okay, so I have this operator here, which qualifies, which serves the same purpose like a pipe. But remember, the pipe operator is coming from the deployer package, but this is coming from the data.table. And I am dropping the geometry using the data.table package. That means I have to, the data.table package doesn't recognize the pipe operator, hereby denoted by the 2 percentages and the greater sign. So that's where my challenge was. And then I can rerun the code again and try to join. So it has worked. Yes, the column names from the two data sets, or rather the data frame and the shapefile are not the same, but I have specified here and told her that I want you to combine, to do a combination using the dist name from the school and understand that this dist name has the same information with the DNAME 2019. So this worked, and we can see that now we have a shapefile that has information from the school and also information from the shapefile. And then another thing I want to do is to check the class of the lat and long columns. And it's numeric. Another thing I want to do is to remember, I want to filter, okay, let me take you back. Remember here when we were transforming from wide to long, we said that the names were to be allocated a column name species, and the values were to go to a column which we call present. True. And this present column is containing the number of children that were that tested positive for any of the species. So in this code, since I want to map the presence, or rather co-endemicity, And then my instincts tell me that if it's a 0, if the presence is at 0, then it means that neither of the species are positive. Like, there were no children testing positive for any of the species. So I want to ignore any zeros from my data set, because what I want to map is presence. And what about presence? Do we have scenarios whereby Mansoni is present and Hematobium is present? So that's why I'm filtering here to only retain positive cases only. And then after doing this, I want R to recognize this as a shapefile. So I'm using a function set as SF, this one. So let me see what I have if I exclude the set as a SF function. And then class. It is a data frame. But remember, we want to plot a map. So you cannot plot a map on a data frame. You only plot maps using data types that are a data with an extension of SHP. That means you only plot using shapefiles. So that's why I am using the function set as a self, and R is clever enough to do so because it will recognize there is geometry. If I try to set as a self on a data frame without geometry, R will give me an error. So after doing that, we now move to creating our map. And this map will contain schools. And in the schools, we will color using different colors to show the different species. So we will show schools where Hematobium is present and Mansoni is present. So once I plot these maps here, we go back to the introduction about Google Earth Pro Engine. Because what we notice is that we have the boundary here, but then we have most of our schools falling outside the boundary. So we want to ensure that this school is falling inside the boundary. We want to ensure that this school is falling in the boundary. We want to ensure all the schools are falling in the boundary. So at this point, you get to decide if you have to clean the coordinates or proceed. Like this is the point where now you make a decision for data cleaning. I will pause for any question.
Yeah, so Damari, this is great. I can now see the application of what we studied today. So thank you so much. Because when we were flowing, I was struggling to appreciate what we covered today, but now I understand the purpose and the rationale for this. And by the way, I faced this in November last year. So I collected samples from different locations in Uganda. And so I took those samples for analysis, and so I got some positive and some negative. So I wanted to use the shape file for Uganda and for a single district, and I should be able to trace where those samples are. And it's actually some of them were outside. And my supervisor was very hard on me, says, Abel, are you sure you were in the right place? So now this makes sense. And I see the application. I just want to thank you for that.
You're
Over.
welcome. You're
Mm.
welcome. Okay. So is everyone comfortable at this point? Should we continue?
Yes, Damaris, we are comfortable. Though I think if possible, we can stop here so that people can really understand what we have been going through so far, so that we don't take in a lot at the moment. I don't know what Abel has to say about this.
No, I'm in support because we have 13 minutes left. What we could do is that Damaris could share this code and members could go through and yeah, and we see how to continue with the conversation. We could continue with this conversation tomorrow.
Yeah, and maybe to add, you can go through the script in on your own R software, and then in case you get any problem, you can keep on posting on the group, and she'll be available to help you on the group still, in the WhatsApp group. Thank you, Damaris, for the insightful session, and yeah, thank you for that visual that you've showed us of the cases in APAC in the schools. Thank you so much. It was very informative.